Good day guys, being here. So let's continue this exercise. So last time we uh, we modeled we created sorry we modeled this start post and end post. So just use one Baluster family, and then of course we flip it so to create two different one. So today we'll continue adding stuff into this. So as we can see, we have these 1 2 3 4 non-continuous rail in this where's my hell, oh there sorry, in this, so we have this non-continuous rail, right? 1 2 3 4. We're going to add 4 horizontal member into this start or end post, so we can continue this to stop at this vertical member. Okay, so let's start. So first, you should be able to find this file from the last time, 24072. Okay, so first go to family, right? So go to family. So on the railing, so you will be able to find this family 1, family 1C. So they are the rail, the start post, right? So let's go have a look again. So baluster placement, start post and end post. Okay, and right click on this name, edit. So we will be able to open this post family. Okay, so baluster, sorry, and then go and then because we have this as a nested family, so another generic model nests into this family, so we can just select it and edit family. Okay, so now go to left, and this is where we we create this sweep. Looks like something's that's fine. Let's just maybe just align. Okay, yeah, all good. So now we need to add some horizontal member, and also these horizontal member need to be adjustable. Like when we change the slope angle, they need to follow that angle. So what I'm going to do is copy this reference line, just copy it down. So roughly, doesn't need to be precise like spacing or just 1 2 3 4, and then we just we need to align AL this reference plane. Looks like this one lock. Okay, and also 1 2 3 4 we need to lock this endpoint. So click on the reference plane AL, click on the reference plane, tab, and click on this endpoint. So just lock the endpoint of these reference lines onto this reference plane. Okay, so last one, all good. And then don't worry about this because we don't have parameter to control the spacing. So we're going to add some dimensions of DI dimension at 1, at 2, at 3, at 4. So the reason why we add them separately instead of create one running dimension is we need to select them and create a parameter for this. So I'm going to create call this S for spacing, and then type parameter. So now we can control, right? So control, but we still need to so let me just go back to this family. So currently, so in this railing, so this non-continuous, we have 100, 300, 500, 700. So which means that if I go to elevation, so if I measure, so I'm going to use copy to measure. Sometimes you can do this, sometimes I do this, right? So instead of trying to dimension, because in 3D view you can't really, it's a little bit tricky sometimes. You need to set a plan before you dimension. So I usually just try to copy, pretend I want to copy, and then this just give me the number, right? So 200. Okay, so this horizontal 200. How about this one? So try again, CC, and this time it won't allow me to copy it down, so but that's fine. I'll press Shift, still 200. So which means, so the vertical distance between all these railings are always the same as the number we have. Sorry, not here, here. So between these, so for example, 100 to 300, that's 200 difference. So it will always be 200. So now let's go back to here. So currently we have this as spacing, but we want to control this spacing to achieve a certain number between vertical distance from here to here. So how can we do that? So I'm going to do a screenshot to show you how we can get some formula to do this. So if I do this, connect this one perpendicular, create a triangle, right angle triangle, right? So this will be 200. So we need to achieve 200 for this one. And currently this one is S, and we have this angle. So this angle equals this, which is the slope angle, same as this one. Okay, so this equals that one. So in this triangle, we know that so this is cosine A. So if this angle is A, equals S divided by 200, which means S equals cosine A times 200. So of course, if you want to, instead of 200, you can also create a parameter, so you can control this spacing. Okay, so and you just need to replace this 200 with that that parameter. But for this exercise, I'm just going to use 200. Okay, so S equals cosine A times 200. So now go to family types. S equals cosine bracket A times 200. So this should give us a number, so 187.9. Apply. Okay, so now if I try to copy this one up, it will give us 200, right? So that's 200. So you can also do dimension, but yeah, 200. So now we have these reference lines. We can start to model these horizontal members in. So, and also before we do that, I want to increase the height. So at least when I model this one, it's it can be joined with this vertical member. So let's go edit type, sorry, family type, and I'll just change this one to 900. Okay, so now let's go to, you can do it in this view, so it will be the same. So you can create a sweep, pick path, pick this, finish, and edit profile, and go to any of these views. So and then we can just create a circle and give it radius 20, so which makes this a full 40 mm diameter, right? So finish. So now let's have a look. So maybe go to left view, because same as this one, we want a vertical cut instead of like this perpendicular to this reference line. So we're going to edit sweep, pick path, just extend this a little bit, and finish. Okay, and finish. And then because we still have a vertical, a void, so you can see you can pick this void by just here, by move your cursor around here, so around where we cut this solid. And so can you cut geometry, pick this one, and move your cursor around here and cut. So this will also cut this bit. And then for this bit, you can just join geometry, click here and click here. So this is it. Okay, so this is if you want to do it in elevation. So you can also do it in 3D view. Okay, so I prefer to do it in 3D view because I don't need to switch views when I try to create path and profiles. So okay, so previously we turned off the annotation. So type VV, go to annotation category, tick this box. So this will bring back all the dimensions and reference lines. So maybe we need to change the scale, so these dimensions are smaller, so we can see what's behind, right? So you can also move them away if you want to. So now we can see all the reference lines here, so we can start to do this sweep in 3D view. So pick path, pick this, escape once. Okay, so the reason why you need to escape is if you pick path and if you do not press escape, you will click again, it will just remove it. Okay, so just let's do it again. Pick escape, then you can select this and drag it a little bit. Finish, edit profile, create a circle directly in the same view. Okay, so finish, join geometry, this, cut geometry, this and this. Okay, all right, so very easy, right? So sweep again, pick path, this, escape, select, drag, finish, edit profile, circle, this, 20, finish, join geometry, this, cut geometry, this and this. And last one, create, sweep, oh sorry, wrong one. Create, sweep, pick path, pick, escape, select, drag, finish, edit profile, circle, this, 20, finish, join geometry, this, cut geometry, this and this. So now we have this one. Okay, so and let's have a test. So if we change the, so for example, what's that? Slope angle. So can, yeah, all good. And yeah, all these are should be fine because we have already tested them. So now we can load this one into the family. Okay, so into the Baluster family first, and then load this one into the project. So this short, see, we will replace this start post. Okay, so as you can see in this one, horizontal one, it's perfect. So although there's a line between them, but you can, if you turn off the show edge, you'll see it's perfectly, you're matching the height of all these horizontal railing. Okay, so but in this one, so there is some difference in the height of these railings. So we will fix this later. But for now, let's just create another one for this one. Okay, so let's GD again, graphic display option, GD shortcut. Instead of go into this family and try to create it again, I'm going to just delete this family, and then right click on this one and edit. Okay, so now we need to go to left view, so I'm going to need to flip it. So type VV and make sure this copy is not ticked, and click on this, so this will flip this, and then go into this, edit this family. Just in this family, we just need to put a negative in front of this angle, so, and click OK, and that's it. So now load this one back into the Baluster family and overwrite, and let's have a test. So if this was done correctly, when it turned 20, it go this way, see? Right? Because this is the end point, so it should go this way. So this is all good. Let's load this one into the project and select. Oh, hang on. Sorry, wrong. I should have changed the name before I load. That's fine. I'm going to let me think. Okay, so I'm going to edit this family first. Okay, and go to the project and Control Z, so it will reverse back to the previous one, but this one's still the latest one, right? So we just need to save as a different name. Sorry about that. So yeah, if this happens, why I name it AC anyway. So let's just overwrite. just give it a different name. Then you can load this one into your project, and then you will have a so first one and then the new one. Okay, so we just need to go to edit type, go to Baluster placement, go to here and post, and pick the one we just change the name, right? So click OK, apply, and now we have this. Okay, now it's almost there. So first, before we go into this bit, so just because currently it's still not perfect, don't know why. Okay, don't know why, but we will try to fix that. But before that, just quickly, so if you want to change the how Revit plays this regular baluster, so regular baluster, so you can adjust this. So for example, you can change to center, you need to apply, or you can just change it to spread pattern to fit, something like that. Okay, so now let's go check these. So this is a little bit tricky one because I don't know why this is happening. Okay, I didn't know. I know. I still don't know why this is happening. But at least we can fix this. I'll show you why. I'll show you how. I don't know why. So yes, so this is very weird. So this difference of height. So if I try to shift the copies, that's 4.7 mil difference. Okay, so I spent some time trying to figure out why, and try to figure out and also this number is different. If you, so for example, if I create a floor, okay, because I want a specific angle, so it's easier for me to just create a floor. If 5 meter by 5 meter, I'll finish this and use modify sub element, click on this, raise this up by 5 meter. So this will give us a 45-degree slope angle on this floor. Now I'm going to copy this one to under the floor. Just make sure it's under the floor, and pick new host, pick the floor. So the slope angle of this railing is now 45 degree. So, and then I go check the height of this one. I'll try to copy this one with shift. It gives me 8.3. So I did some test, and what I use is so this is 40 mil, okay, and this is 45 degree, so which means as square root of 2 times 40, okay, so equals I need a calculator. So square root of 2 is 1.414, okay, so times 40 equals 56.56, and then I just use this number minus 40 gives us 16.56 divided by 2 gives us 8.28. So this is very close, 8.3. And then I tried some different angle, so tried a different angle and worked out that this little height difference always equals this 40, which is the diameter of this railing, so always 40 divide by cosine A, which is a slope angle, minus 40 bracket divided by 2. It always equals this one. Okay, so which means if we add this formula, add a parameter using this formula, and then adjust the height of the baluster, we can perfectly match the height of the railing. Okay, so let's do this. So what we need to do is go into this Baluster family. Let's go to let me think. Okay, so we need to go into this one as well. So go into this family, go to left. Okay, so I don't think we need to do a lot of change, but first we need to add that little height difference. I'll just call it ADJ. Okay, so adjustment. Anyway, and it will be type, and I'll just put that formula into it. So it will be 40 divided by cosine A minus 40 bracket divided by 2. So you will see it gives us for now with a 20-degree angle. So it gives us 1.3. I'll try positive. Yeah, it's the same, right? So that's fine. So we have this one, and then we need to lower the height, lower the overall height of this one. So currently this height is this one. So let me think, which means we need to have okay, so we need to create a height, another height. I'll just call it H2. H2 need to be H2, sorry, I need to H minus ADJ. Okay, so H minus ADJ. So when the height, so if the the railing in the project, when we set it to that, the actual need to be this one, need to be H2. Okay, so good. So I'm going to just swap this one instead of having this H controlling the actual height of this baluster. We're going to use H2 to control. So you will see it actually lower it slightly. Okay. Let me check. I think that's probably it. Let's load this one into the Baluster family and overwrite, and load this one into the project, and let's have a look. Okay. Something's not quite right. Looks like okay, so let's go back. Must be something's not right. Let's have a look. Why this is happening? So H1 tangent offset plus H plus R. Yeah. So I think it's very likely this one, this formula. So because previously we always use this H, this is H, we use this as to adjust the H1, right? So adjust this one. So we probably just need to change this one from H to H2. So click OK. Yep. Okay, so let's try again. Load this into family 1, sorry, family 2 or family 1 and load this one back into the project. That's it. Now you can see it match the horizontal non-continuous railing perfectly, right? So great. That's what we need. So if we edit this, lower this down a little bit, change the slope angle, let's have a look again. Still perfect. Okay, so now what we need to do is just replace this one. So it will be yeah, you have an option, so you can just delete this again, and create this one with this one, or you can just go into this one. It won't be hard, so let's just go into this one and edit this again. So just need to create that ADJ, right? So let's call it ADJ. Click. It will be bracket 40 divided by cosine A minus 40 bracket divided by 2. So this will be the formula. And then we change this one to H2, and we also need to create, oh sorry, we don't have an h2 yet, so we need to create a formula, a parameter for h2. h2 equals h minus adj, and then replace this with h2. Okay, so finish this, and also one last step, go to here, go to the elevation, we need to swap this one with h2. So this is it. Now load this one into the Baluster family and overwrite, and load this one into the project and overwrite. So now you will see perfect, right? And this is it. So horizontal, on slope, on stairs, they are all perfect, right? Yeah, so this is it. Yeah, no, it's a little bit tricky. Stairs, it's always very hard to, you know, edit or adjust. Yeah, but it's good. Because of all these requests, I have to spend time to try to figure out what's going on, how to, make them work. So yeah, that's good. So yeah, if I will upload this family for you so you can have a play. If you have any questions, please just post your question. I need to drag it here. Just need to, I need to go to my, please ignore all this. Yeah, just post here. Okay, so thanks for watching, and I'll see you next time. Thank you. Bye.